Alright, so we left off over here where we have our go to and from tags, and now we have our circuit over here on the right. So now we're getting ready to run our simulation. So again, this is a simple electrical circuit. We have just a capacitor, 1 millifarads, a resistor, 10 ohms, and we define those here inside the blocks. We have a control source that the voltage for that control source, or controlled voltage source that is simply the simulation time times 5, and that's going to be the output of the voltage source. So at t equals 0, the output of the voltage source is going to be 0 volts. At t equals 1 second, the output of the voltage source is going to be 5 volts. At t equals 2 seconds, the output of the voltage source is going to be 10 volts, and so on and so forth. So again, this stop time over here is what we call the simulation time. So this is how long the simulation is going to run for. And again, remember that that's not actually how long it takes for your computer to run the simulation. What that is the time that the simulation runs in real time. So in other words, Simulink is going to say, okay, this is what the circuit would look like for 3 seconds in real life. It doesn't necessarily mean that it's going to take your computer 3 seconds to run. What it means is that Simulink is going to present the results as if the circuit had run for 3 seconds. So let's change that to 3 seconds, and I'm actually going to try to run this simulation now, and we're going to get an error because we need another block that I haven't added yet. But I want to show you that if you don't add that block first, you're going to get an error if you try to run a simulation. So I'm going to go ahead and click run, and again we get an error over here. It says each physical network, and again remember that physical networks or physical signals are these ones that are colored in Simulink. Each physical signal, or rather each physical network, must be connected to exactly one solver configuration block. So it sounds like we need this separate block. There is no solver configuration block connected to physical network with the following blocks: the capacitor, the voltage source, the reference, or meaning the ground, the resistor, and the Simulink to physical signal converter. So what this is saying again, and I knew this before I ran the simulation, but what it's saying is that we need what's called a solver configuration block. And we can find that, of course, here in the library browser. So I can search here then for a solver configuration and do a search for that. And that's this block over here. You can also find that one here under Simscape, and all the way down to utilities. It's over here. So let's go ahead and add that to the model. And let's go back to the model now. And we see it over here. And basically, again, that error said each physical network, meaning networks like this that are colored, needs to be connected to a solver configuration block. So what this is essentially is a configuration block that tells Simulink how to run the simulation. For example, it tells us what's the consistency tolerance that you want during your simulation. Now, these parameters are usually fine if you leave them at default. However, if you run into errors, you might want to change some of these parameters. So for example, this consistency tolerance, what that means is, okay, let's say that I'm computing the voltage across this circuit over here. Simulink is going to run the simulation and it's going to find, okay, what are the results and are they consistent with each other to this level of detail. So if you make this a little bit bigger, that's telling Simulink, okay, I don't need the solution to be that detailed. I'm okay if there's a little bit of error in the simulation. And of course, 1 times 10 to the negative 9 is a pretty tight margin, so a pretty tight tolerance. So meaning that your result is going to be very, very accurate. And again, usually these are fine if you leave them at default. So let's go ahead and click OK on that. And now we should be able to run the simulation. So now if I hit run, it should run and I shouldn't get any errors, and Simulink should be able to just run the simulation. So let's go ahead and click run, and there it went. I didn't actually get any errors. It ran the simulation Now, I haven't added a scope, and we're going to do that in the next lecture, but the simulation ran just fine. Everything's fine. Of course, I can't see results because I don't have a scope in my model. But I want to show you one thing over here, and that is that if I change this, let's say to 1200 seconds, so that would be 20 minutes worth of simulation. You're going to notice over here a bar that's going to come up, and that's going to be basically Simulink running the simulation before it presents the results. So if I click run, and this is actually a very simple circuit, so it didn't take long to run the simulation, but let me actually run it again and see if you can see that percentage that comes over here. So let me run it again. You see that it first says set compiling and then a bar with a percentage. So it goes from 0 to 100% very, very fast because my computer is running the 20 minutes worth of the simulation very fast because this is a very simple circuit. So let me actually change this, let's say to, so that was 20 minutes, so 200 minutes, 2000 minutes. Let's go ahead and run. And same thing, this is a very simple circuit, so it's not taking too long for my computer to run the simulation. But what I want to show you is that if you have a very complex circuit, the simulation time is going to take a little bit longer. Now here, because we have a very simple circuit like this one over here, it's not taking very long to run the simulation. Now, one more thing that you could do if you wanted to see everything go in real time, you can say, okay, if I want to run the simulation for 20 seconds, I can slow down the simulation time. So I can go here where it says run and click on this drop down and go to simulation pacing and click here where it says enable pacing to slow down simulation. So what this is going to do is going to say, well, if I'm running 20 seconds worth of a simulation, my computer is going to run the simulation in actually the same time as the simulation time. So again, remember that there's two things. This time over here is essentially how long do I want to run the simulation and have Simulink give me the results for it. So in other words, if I put 20 in there, that means the Simulink is going to tell me, okay, these are the results as if this circuit had run for 20 seconds in real life. It doesn't necessarily mean that my computer is going to take 20 seconds to run the simulation, as we saw before. In fact, if I simply click run over here, and I'm actually go back and disable the simulation pacing, and I click run, you'll see here down that it says compiling, and then 0 to 100 it goes very, very fast. You almost can barely see it because again, my computer is running 20 seconds worth of simulation very fast, probably milliseconds. Now, if I wanted to see the results in the same time as the simulation time, I can say, well, enable pacing and do a simulation time per wall clock second 1. What that means now is that when I run the simulation and I'm running that for 20 seconds, now my computer is going to take 20 seconds to run the simulation. So let's see how that works. If I click run now you see it goes 1, 3, 2, 3, 4, 5, 6. So this is actually taking the same time as the 20 seconds over here because I paced the simulation down such that the time that my computer takes is equal to the time of the simulation. And you can also see, let me run this again, you can also see the percentage over here. So it goes 10%, 14, 18, 22, 26, 30. So again, what I did now by pacing down the simulation is now I'm telling my computer, don't run the simulation as fast as you can. Instead, I want you to run the simulation at the same time as the simulation time. So if I want you to present the results for 20 seconds worth of the circuit, take 20 seconds to run the simulation. Now, usually you don't want that unless you're watching the scope in real life, as we're going to see here in the next lecture. So let me go ahead and disable this pacing. And again, when I run this even for 1200 seconds, it runs very fast on my computer because again, this is a very simple circuit. All right, so in the next lecture, we're going to see how to take measurements to be able to see the performance of the model.